Imagine something so extreme. It makes a black hole seem almost normal in comparison. And it's not just big, it's got a super strong magnetic field. That's what a magnetar is. Well, it's kind of neutron star, but it's not just any neutron star, it's a supercharged one. It has the most powerful magnetic field in the whole universe. It is really powerful. It is so powerful, it can kill you from very far away. That is why people call it deadly. Most stars end their lives in a big bang. This is called a supernova. If a star is big enough but not too big, its core collapses. It doesn't become a black hole, it becomes something else. It becomes a neutron star. A neutron star is tiny. It is only about 12 miles across. That's like the size of a city. But it has more mass than our sun. Imagine squeezing our whole sun into something the size of a city. That is a neutron star. It is incredibly dense. A teaspoon of neutron star material would weigh billions of tons. Neutron stars spin very fast. Some spin hundreds of times a second. They also have strong magnetic fields. But a magnetar is different. It takes the idea of a strong magnetic field and turns it up to 11. Its magnetic field is not just strong, it is unbelievably strong. Let's think about magnetic fields we know. Your fridge magnet is weak. Earth has a magnetic field. It protects us from space radiation. It's pretty strong. The sun has a magnetic field. It's much stronger than Earth's. But even the sun's magnetic field is like a tiny whisper compared to a magnetar. A magnetar's magnetic field is 1,000 times stronger than any field we can create in a lab. It is a million billion times stronger than Earth's field. That's a 1 followed by 15 zeros. A million billion. It's almost impossible to imagine that kind of power. How do magnetars get such crazy strong fields? It's all about how they form. When a big star collapses, it spins faster. It's like an ice skater pulling in their arm. They spin faster. This rapid spin helps generate the magnetic field. It's called a dynamo effect. But for a magnetar, something special happens. The star that forms it has to be big. It also has to be spinning incredibly fast just before it collapses, and it needs a pretty strong magnetic field to start with. When it collapses, this field gets super compressed, it gets amplified. This is how it reaches those mind-bending levels of power. These fields are not just for show, they have huge effects. Imagine being near a magnetar. Well, you wouldn't exist, your body would be ripped apart. The atoms that make up your body would be stretched. They would be elongated, they would distort. The forces would be too great, not just your body. Anything made of matter would distort. Even light. Light itself would bend, it would polarize. It would do weird things in such a strong field. We call this vacuum birefringence. It's like the space around a magnetar isn't empty anymore. It's filled with this invisible, powerful force. Magnetars are not quiet objects. They are active, they burst with energy, they sometimes have giant flares. These flares are like starquakes. The crust of the neutron star cracks. The magnetic field lines get tangled. They snap, and when they snap, they release an enormous amount of energy. This energy comes out as X-rays and gamma rays. These bursts are very powerful. They are sometimes called soft gamma repeaters, or anomalous X-ray pulsars. These are just names scientists use. They mean the same thing. They mean a magnetar is having a tantrum. One of the most famous magnetar flares happened on December 27th, 2004. A magnetar called SGR 1806-20 burst. It was much farther away than the center of our galaxy, but it was so powerful it still affected Earth. The burst was brighter than the full moon in the sky. It lit up our atmosphere. It ionized it. It was detected by satellites, even from that huge distance. It released more energy in a few tenths of a second than the sun produces in 250,000 years. That's a lot of power. Just think about that. A tiny star, far away, lets out that much energy in an instant. It shows how truly dangerous these things are. The deadliest part isn't just a fun name. If one of these flares happened closer to us, it would be a very bad day for Earth. If a magnetar was within, say, 10 light years of us, a flare could wipe out life. It could strip away our atmosphere, it could fry our electronics, it could cause mass extinctions. Luckily, the closest known magnetar is much, much farther away. It is thousands of light years away. So, we are safe from direct harm, but it gives you a sense of their power. It shows why they earned that scary name. Scientists study magnetars using telescopes. They look for X-rays and gamma rays. These are the signs of a magnetar's activity. They watch for the flares. They also listen for their pulses. Like, Other neutron stars, magnetars, spin. As they spin, they send out beams of radiation. If these beams sweep past Earth, we detect them. This lets us measure their spin. It helps us understand their internal structure, but magnetars are often very dim. They are hard to see, until they have a big flare. Then they light up the universe. And their magnetic fields don't last forever. They decay over time. As the field decays, the magnetar gets less active. It stops having huge flares. It might turn into a regular neutron star, or it might just become a quiet old object. This decay process takes about 10,000 years. That's a blink of an eye in cosmic terms. So, magnetars are relatively short-lived phenomena. This makes them even more interesting. We are lucky to catch them during their active phase. Scientists are still trying to figure out all the details. How exactly does the magnetic field get so strong? What causes the flares? Is it just the crust cracking? Or is there something deeper happening inside the star? These are tough questions. We can't go to a magnetar. We can only study them from far away. We use math. We use physics. We use telescopes. It is like solving a very complicated puzzle. One of the big new things about magnetars is they're linked to fast radio bursts. FRBs are mysterious flashes of radio waves. They come from far, far away in space. They last only a few milliseconds, but they are incredibly powerful. For a long time, no one knew what caused them. Then, in 2020, scientists found an FRB coming from a magnetar in our own galaxy. This was a huge discovery. It strongly suggested that magnetars are a source of at least some FRBs. It opened up a whole new area of study. So a magnetar is a super-dense, supermagnetic star. It's small, but it's mighty. It's born from a supernova. It has a magnetic field that can tear matter apart. It sends out powerful bursts of X-rays and gamma rays. It might even be behind some of the universe's most mysterious radio signals. It's a truly extreme object. It makes us think about how powerful the universe can be. It is a neutron star with a twist. A magnetic twist. It's not just a regular neutron star. It's a special kind. It has a magnetic field 1,000 times stronger than even the strongest ones we can make on Earth. That's a field that could erase all your credit cards from 100,000 miles away. If you were closer, it would literally pull the electrons from your atoms. You wouldn't be able to stay together. It's that strong. The material inside a magnetar is like nothing on Earth. It is a superfluid. It is also a superconductor. These are strange states of matter. They happen under extreme pressure and temperature. The magnetic field itself is so strong, it changes the way we think about physics. Normal physics doesn't quite cut it. You need something called quantum electrodynamics. This is the physics of how light and matter interact, but under extreme conditions. And the bursts. Oh, the bursts. Imagine all the light and heat our sun gives off for thousands of years. Now imagine that energy released in less than a second. That's a magnetar flare. It's not a gentle flicker. It's an explosion of energy. It's a shock wave of radiation that races across space. It's a scream in the cosmic silence. These flares don't happen all the time. They are sudden. They are unpredictable. That's part of what makes them hard to study. We have to be lucky. We have to have our telescopes pointed in the right direction at the right time. Or we detect the burst after it has happened. Then we try to trace it back. We try to find the source. This is how we find new magnetars. We find a huge burst, and then we look for the small, dim neutron star that caused it. The intense magnetic field also warps the star itself. It's not perfectly round. It's a bit squashed, it's a bit distorted. The magnetic pressure inside is enormous. It pushes and pulls at the star's crust. It builds up stress. And when that stress gets too much, the crust cracks. That's the starquake, that's the flare. It's like a cosmic pressure cooker. The steam has to escape. And when it does, it's violent. Some scientists think there might be more magnetars out there than we know. They could be quiet, they could be dormant. Their magnetic fields might have decayed already. So they just look like normal neutron stars, but they started as magnetars. This makes us wonder about the lives of all neutron stars. How many of them were once these super magnets? We don't have all the answers yet. That's the exciting part of science. There's always more to learn. The universe is full of amazing things. Black holes suck in everything, supernovas explode, but magnetars have their own special terror. They show us a different kind of extreme. It's not about gravity pulling everything in. It's about magnetism. It's about a force we usually think of as weak, but magnified to unimaginable levels. Levels that redefine what is possible in the cosmos. And they are not just interesting for their power. They are important for understanding fundamental physics. These extreme environments are like natural laboratories. They let us test theories that we can't test on Earth. We can see how matter behaves under pressures. We can see how light behaves in fields that are beyond our wildest dreams. This helps us understand the universe better. It helps us understand the very building blocks of everything. So when you think about the universe's deadliest magnet, you are thinking about a magnetar. A tiny, city-sized object, but it holds more power than you can imagine. Its magnetic field is a force of nature. It's a force that can distort atoms. It can unleash energy in blinding bursts. It can light up our galaxy from across space. And it teaches us new things about the universe every day. It's a reminder that space is a wild, incredible place, full of wonders and full of things that can scare you, but also things that make you just stop and wonder.